writing I did on the first go around, and I'll explain it very thoroughly. So if we take a look, we have the square root of 6u to the v to the fourth and the square root. And we can't have a square root in the denominator, so we multiply by the square root of 6uv to the fourth in the numerator and the denominator. So then I take this and I multiply it with this, and I get 60u to the fifth, v to the sixth, with the 4 on the outside. Now we look, 60 can take out a square root inside of it. There's a perfect square inside. So if I do 60 divided by 4, I'm left with a 15 on the inside. The square root of 4 is 2, so I take it out. 4 times 2 is 8. Then we look, how many 2's are in 5? 2 of them. So we take the 2 out, and we're left with 1 on the inside. How many 2's are in 6? 3 of them, and there's no left over. Now we look, we have to simplify what's on the outside. So 8 divided by 6 becomes 4 divided by 3. U squared divided by u is u. V to the third divided by v to the fourth is just v, and we leave the inside as is. You cannot change anything inside there. If we look at the next one, we have to multiply by the radical. So we multiply by the square root of 2x squared, y squared, in both the numerator and the denominator. When we do that, the numerator becomes square root of 10x to the sixth, y to the fifth. The denominator has the 5. We act like the square root's not here anymore because it gets rid of the radical. And 5 times 2 is 10, and we leave this as is. Now we look, how many 2's are in 6? 3, so we take it out. How many 2's are in 5? 2, but we still have 1 on the inside, and 10 does not have any perfect squares in it. Now we have to simplify. X to the third and x squared gives me just an x. Y squared and y squared cancel out, and then we just leave everything else where it was. For the next problem, I decided to do the last one with you guys. So we have 2 squared of 5, which just stays 2 squared of 5. There's no perfect squares to take out. We have minus 3 square root of 45. 45, I can take a perfect square of 9 out. So when I do that, I get a 3 on the outside. So negative 3 times 3 is negative 9. And I'm left with that 5 on the inside over here. Then I have negative 2 square root of 20, which we know is 4 times 5. So take the square root of 4 out, and we multiply by that negative 2 out here. We get negative 4 square root of 5, and then we leave 2 square root of 3. But we have to combine our like terms. And our like terms in this sense means that we have same square roots or same radicals. So we do 2 minus 9 minus 4, which is negative 11 square root of 5. And the 2 square root of 3 has to stay the same because we are not doing anything with it. There's nothing we can combine. For this problem, I did the second one. So we distribute in. 5 times the square root of 6 is 5 square root of 6. 3 square root of 3 times the square root of 6 gives me 3 square root of 18. But then we look, the square root of 18 can be simplified to 9 times 2, which takes a 3 out. So 3 times 3 is 9 square root of 2. I did this problem, so I multiply by the square root of 5 because I want the radical to go away. So I have to do it to the numerator as well. And we have to think, I'm not just multiplying the square root of 5 by this term. I have to distribute it to both. So the numerator becomes 5 square root of 5 minus 5 square root of 10. And the denominator becomes 2 times 5, which is 10. And if we look, all the coefficients are divisible by 5, so we have to take that 5 out. If we don't, it's not in simplest terms. And that's what we need it in. So that becomes square root of 5 minus square root of 10 all over 2. Now we look at this problem, the second one I did, and then I did the third one as well. We distribute negative 3 square root of 2 with 2 square root of 2. So negative 3 times 2 is negative 6. Square root of 2 times square root of 2 is 2. So negative 3 times 2 is negative 6, like I said, times 2 is negative 12. For the next one, we do negative 3 times negative 5, which is 15. Square root of 2 times square root of 4 is square root of 8. Take out the square root of 4 inside there, and that leaves me with a 2. So 15 times 2 is 30, and leaves me with the radical 2. The next problem, 5 square root of 5 times 2 square root of 2 gives me 10 square root of 10. And the last one becomes negative 5 times 5, which is negative 25. Square root of 5 times square root of 4, which is square root of 20. Then I know that square root of 20 is 4 times 5, so take the square root of 4 out, multiply by 2, and we get this. And we can't combine any of our there are no like terms. We can't combine any terms, so we keep it as is. For a problem like this, we have to remember we can't just distribute the squares. We have to open it up and FOIL. So 2 square root of 3 times 2 square root of 3 is 4 times 3, which is 12. 2 square root of 3 times 3 square root of 5 gives me 6 square root of 15. Same thing for this one. And then this one becomes 9 times 5, which is 45, because 3 times 3 is 9, square root of 5 times square root of 5 is 5, and multiply those together. Combine our like terms. 12 plus 45 is 57. 6 square root of 15 plus 6 square root of 15 is 12 square root of 15. If we look at the conjugate, this is a very important term. You have to know that if we have two terms in the denominator and one of them is a radical or both, you're going to have to multiply by the opposite sign in between them. And why do we do this? Because if I just multiply by the square root of 3, the denominator would become negative 4 square root of 3 plus 3, and we still have that radical there that we don't want. So I multiply by the conjugate and I distribute. Negative 4 times negative 4 is 16. Negative 4 times negative 4 times negative square root of 3 becomes positive 4 square root of 3. Distribute this is negative 4 square root of 3, and this becomes minus 3. So I showed you guys in class that if we're multiplying by the conjugate, the denominator just becomes the first squared minus the second squared, which gives me the 16 minus 3. In the numerator, we do 4 times negative 4, which is negative 16. 4 times negative square root of 3 is negative 4 square root of 3. Simplify everything, and if we look, if 13 was actually a number that was divisible by 4, we would have to divide everything by 4, but because it's not, we just leave it as is. So now I'm going to try one like the second one here. I don't think we got to it, or maybe we did. No, we did this one. It was a different one. So if we look, I have to multiply by the conjugate, which means this turns into a plus. So if I do the numerator, 5 times 5 square root of 2 is 25 square root of 2. 5 times 4 square root of 5 is 20 square root of 5. 5 square root of 2 times 5 square root of 2 is 25 times 2 is 50. Negative 4 times 4 is negative 16 times 5 is negative 80. Simplify and we get this, and then we look, wait, every coefficient is divisible by 5. So I divide by 5 and I get 5 square root of 2 plus 4 square root of 5 all over negative 6. Now let's look at both these problems. I think we went through the first one, but not the second one, so let's take a look at both. So if I look at the first one, I distribute. Well, I don't distribute yet, excuse me. I look and I say, okay, I need the conjugate, so I change this to a minus sign. Now I distribute and I get negative 3 square root of 2 plus 12 square root of 3 plus 2 minus 4 square root of 6. I just did my foiling. The denominator becomes square root of 2 times square root of 2, which is just 2. 4 square root of 3 times negative 4 square root of 3, which is negative 16 times 3, which is negative 48. We leave everything as is in the numerator and simplify the denominator, and we get negative 46. If we look at all the coefficients, they are not divisible by anything alike. So we just keep it as is. We can't combine like terms, so it just stays like that. For the next problem, we take a look. All right, this is a plus, so this will be a minus. I distribute. Negative 3 times 5 is negative 15. Negative 3 times negative 3 is 9, square root of 5. Negative square root of 5 times 5 is negative 5 square root of 5. And this becomes 3 times 5, which is 15. If I combine my like terms, these cancel out, and I'm left with 4 square root of 5 in the numerator. If I look at the denominator, 5 times 5 is 25. 3 times negative 3 is negative 9 times 5 is negative 45. And when I subtract, I get negative 20. If I look at all these, I can divide by 4 in the coefficients, so I'm left with square root of 5 over negative 5. And that would be my final answer. Now let's take a look at something like this. It gets a little bit messy, so I think on the test, I'm just going to give you one like this. On the review, I gave you ones like these. Maybe I'll adjust it. I'll think about it within the next few days. But if we look, I did in class the 3 plus the square root of 6. So I'm going to show you the 3 minus the square root of 6. On the test, you're going to have to do both of the options. So make sure you can do both of them. You're going to have to do both of them. We ran out of time, so I only showed you the positive. But if we do the negative, we plug it in to the x. And we get 3 minus the square root of 6. 3 minus square root of 6 plus 3. We know that this means we have to FOIL. So 3 times 3 is 9. 3 times negative square root of 6 is negative 3 square root of 6. Same thing here. And this becomes plus 6. We distributed it here, and we got negative 6 times 3, which is negative 18. Negative 6 times negative square root of 6, which is plus square root of 6 square root of 6, plus 3. And then if we combine our like terms, 9 plus 6 plus 3 is 18. Minus 18 gives me none. 6 square root of 6 minus 3 square root of 6 minus 3 square root of 6 gives me 0, which is what I wanted. When you have solutions, you want them to be 0. And then down here, I attempted the second one here. We have 4x squared plus 10x plus 3. And I said to use the quadratic formula and then to plug in to show it works. So we have negative b plus or minus square root of b squared minus 4ac all over 2a. I simplify it and I see 52 is divisible by 4, so I radical that out. Then I see everything's divisible by 2, so I leave it as this. These are my two answers. It would be negative 5 plus the square root of 13 over 4 and negative 5 minus the square root of 13 divided by 4. I chose to show you the positive because I don't have a lot of space, but if I was to give you a problem like this, you would have to show me both. So I know that if I'm squaring it, I have to multiply them twice. So 4 times 4 is 16. Negative 5 times negative 5 is 25. Negative 5 times square root of 13. Negative 5 times square root of 13. Combine them gives me negative 10 square root of 13. Square root of 13 times square root of 13 is 13. Combine my like terms, I get 38 minus 10 square root of 13 over 16. And I see everything's divisible by 2, so I divided everything by 2. And we still have that 4 on the outside of here, so I multiplied by 4, which just simplifies the denominator to 2. So I have that down here. Now I need to take this and multiply it by 10, the plus square root of 13 and such, by 10. But if I look, 10 times 4, 10 divided by 4 is the same thing as multiplying by 5, and this would be 2 in the denominator. So that's what I did here. I distribute the 5 in. So 5 times negative 5 is negative 25. 5 times the square root of 13 is 5 square root of 13. And then I want everything in the same denominator, so I change the 3 to 6 halves, so 6 divided by 2. And if I look, we can get rid of the 2's because it's the same thing as the denominator, and I do 19 minus 25 plus 6. That becomes 0. Negative 5 square root of 3 plus 5 square root of 3 cancels out, so that becomes 0. And I know that was a lot to digest, so I will go over probably this one next class. I'm going to give you the answer and those two solutions, and then we'll plug it in together so we're able to figure that out. On the review, I didn't give you the answers, but I will give you the two solutions so you're able to plug it in, because if not, it takes a little bit long, and I know you know how to do the quadratic formula. All right, so that is how you complete this problem. If you have any questions, please email me.